Hello, everybody, and welcome to today's webcast, Revolutionizing IoT Testing, a sneak peek of a new HiveMQ tool. We will kick off in a minute, but before we start, I want to let you know that all participants are muted. However, you can ask questions during the webcast by clicking on the Q&A tab in your control panel. There will also be around 15 minutes Q&A session after this presentation, and we will answer your question there. If we can't answer them all, we will answer them on the HiveMQ community forum. So I will share the link with you afterwards. We will also start a quick poll during the Q&A session and would be pleased if you give feedback and participate in the poll. And I also want to let you know that we record the session and we will share it with you afterwards. All right, and now I'm happy to welcome today's speakers. So Georg, if you go to the next slide, please.
I think Dominik already has control.
The next slide. Yeah, Dominik Obermaier, who is CTO and co-founder at HiveMQ, and Georg Held, who is engineering manager at HiveMQ, and they will introduce you to our new IoT testing tool. So I'm happy to hand over to Dominik.
Thank you, Verena. So also a welcome from my side. As Verena said, my name is Dominik Obermaier. I am the CTO here at HiveMQ. So in case you'd like to learn more about MQTT, new things like Sparkplug, but also technologies in general. So here is the contact data of me and also from Georg. Feel free to connect, to reach out, and I'm happy to have any discussion also afterwards, in case this is interesting what you will see today. So what you will see today is, Verena already announced it. We are going to show you a new product which is now available as early access as we speak, called HiveMQ Swarm. But before we dive into what HiveMQ Swarm is, let us talk about what are the actual problems we saw over the years working with large Fortune 500 companies, the largest IoT deployments in the world, with literally tens of millions of connections, of MQTT connections, and also working with most major automotive companies for the connected car use cases, as well as a lot of industrial IoT use cases. So there are a few challenges we found, and also there is still a blind spot currently with a big problem. A lot of companies are struggling as we speak here. And let us talk about why IoT testing is important, and why IoT testing is actually something that is quite different to traditional testing people might be familiar from web applications. So first of all, and this is, I think a lot of companies can relate who have connected products out in the field, especially if they have it at the customer hands, is that fixing IoT production errors are very costly to fix in the field. And they are much more costly than traditional applications you can usually fix by deploying new software versions on your backend. Because if you have, let's say, a problem with the firmware, let's say in a connected car, it's pretty costly to update. Because if you're lucky, you can update it. But if you're not lucky, you cannot update it. And there are some examples. For example, here in Germany, Volkswagen had a huge issue with recalling their cars because they could not update software remotely. And so fixing errors is really costly. And it's not only about bugs in the firmware or in the software you have at your devices. It's also about contracts. So if your teams are building applications for a device, but also have backend components and so on, the contract, which means what kind of data is exchanged and so on, is pretty important. And actually most let's say errors we've seen in the field are based on these kind of issues, because the contracts are not enforced somehow. And then if you go live with your backend, with your devices, ship it to customers, sometimes this is getting a huge problem. And why is this getting a huge problem? Because most companies deal with large quantities of devices. So, I mean, a connected car use case is pretty obvious. There are literally companies who sell millions of cars or even more than 10 million cars per year. Most of them have connected functionality. And most of these companies use actually MQTT today. But if you think about the system, you have devices, you have MQTT brokers, you also have databases, other applications, streaming platforms like Kafka, and all in the mix. And what you really want to do is an end-to-end load and stress test of the capabilities of your whole platform. It's not about that you just test your broker or you just test, let's say, the one microservice. You really need to test everything together and the whole behavior of the system, which can be quite organic for many use cases. And last but not least, a lot of companies are struggling to predict their cloud costs and the infrastructure costs that they need to run their software in the cloud. And very often things like traffic play a large role in the cost structure. And we have seen customers who were basically surprised by their cloud bill, not because of our, let's say, HiveMQ cloud bill, because this is predictable, but based on their own applications they host in the cloud. Why? Because traffic is something that really costs a lot of money. And in order to predict that, you actually need to test it. It is so hard to predict what traffic and actually consumption will cost the cloud providers if you do not test it. And so this is one of the important parts. And this is so hard to do right now. So it's really about the challenges when you look at it. We have this massive distributed systems with sometimes literally millions or at least thousands of devices. And then you have a distributed system of microservices, databases, applications, and so on, which all need to work as a single piece in order to basically provide your business use cases. And the problem is the test environments usually are extremely different from production behavior. So while there are some companies, and we see this sometimes, especially in the industrial IoT world, where many companies struggle to have a test system at all, it's very rare that you see a test system which has the same components, the same workload, the same usage patterns as in your production systems. And the same is also true for connected car and any kind of connected products. And so what happens is a lot of companies are basically just emulating a bit of their behavior and then call it a day and hope that it will not explode in production. Because you have a lot of very complex patterns and behaviors, especially if you give the product into the hands of the customers. If you're in a, let's say, an IoT setting, things are usually a bit more predictable, but even then it's not always as predictable as companies hoped. And last but not least, testing at a massive scale, which means like testing literally millions of MQTT connections, which means millions of open TCP connections to a system is extremely hard to do. And the tools we have today are not suitable for that. And just as a quick example, what is not doable right now with most tools on the market is something like this. Basically simulating a fleet of devices across the globe with real latencies, real network, which you then basically run against your MQTT broker infrastructure and your services, which are used or are connected to the broker infrastructure. And this is something we see that a lot of customers are asking for exactly that. And the huge problem, and this was also true for MQTT. This is also why MQTT actually exists for IoT. And this is the technologies we built for the Internet of Humans are not suitable for the Internet of Things. So things like HTTP are not suitable for the Internet of Things at scale. And this is why technologies like MQTT exist. But the problem is the testing tools we have today. There is JMeter, there is Scatling, and a lot of other testing tools out there. They are really built for web applications. They're built for web workloads, but not for IoT workloads. And there's still a huge gap we saw in the market here. And this is also something a lot of our customers basically asked us to finally address the problem. And this is why today we're introducing a new product we call HiveMQ Swarm. HiveMQ Swarm is a distributed platform that is able to create millions of unique network connections And it's really built around MQTT. You can simulate with HiveMQ Swarm millions of devices, messages, and MQTT topics. So you can really test extreme scale against any MQTT infrastructure. HiveMQ Swarm allows you to develop reusable scenarios that simulate device behaviors. And this is a huge deal because you have a descriptive way of modeling how things should behave, and then you just run it. And things like scale, for example, how many things we run are literally just parameters. And HiveMQ Swarm, and we'll see this in a few minutes, and HiveMQ Swarm is smart enough to figure that out for you, distribute load intelligently, also globally, to all the load generators. Speaking of load generators, so while for a simple stress testing, sometimes it's enough to basically just simulate a lot of MQTT clients, simulate a lot of MQTT publishers and subscribes and so on. But HiveMQ Swarm is also built for other use cases, like not just load testing, it's also about functional testing. So very often your applications expect a specific data format. For example, expect a JSON format or a protocol buffer format or something else. And there are custom data generators available for HiveMQ Swarm, which allow you to basically program with a Java SDK, which we will also see in a few minutes. You can program your use cases directly, and even the most complex data formats, and even if you have data which is expected to look like in a very specific way, you can do that and generate it based on your business requirements. And so this is really interesting. So for example, there are for IoT, one of the, I would say, most important specifications out there currently with a lot of traction, like Sparkplug. You really need this kind of data generators. And for example, HiveMQ Swarm is also able to generate Sparkplug workloads based on these custom data generators. HiveMQ Swarm is resource friendly. You can deploy it anywhere. This is not a hosted solution. You can run it on your local machine. You can run it in the cloud on any cloud provider. You can run it on Kubernetes, on OpenShift. HiveMQ Swarm is truly portable. And this is important because there are a lot of use cases where you want to utilize, have some load generators on AWS, on Azure, in different regions, for example. So this is a true multi-cloud solution, which you can operate yourself and host yourself. So this is not a software as a service offering, but this is also a software you can deploy where you want. So the use cases companies use HiveMQ Swarm for is load and stress testing is an obvious one because there's simply not a tool out there which can create that kind of load that easily currently. Capacity planning. A lot of companies are using Swarm and are looking to using Swarm for quality assurance testing, like add it to your continuous integration and also your CD pipelines, your continuous deployment pipelines, in order to make sure that, let's say, if you deploy a new microservice, which is consuming MQTT messages, that it behaves correctly. And so this is also a quality assurance tool people find it very useful for. Our customers are also using it for testing their own HiveMQ custom extensions. This is a use case a lot of companies do have in case they, let's say, integrate the MQTT broker infrastructure and enterprise infrastructure. So there are people can develop HiveMQ custom extensions for that, and they can test it with Swarm. Also, IoT scenario testing is something very important, and device rollout simulations. So we very often have cases where, for example, in the connected car space, there is a new, let's say, firmware version companies want to roll out to parts of the fleet or to even just new models. And this allows companies to simulate what would happen if we roll out the new version of the firmware with a specific behavior to specific parts of the fleet. How would the backend load, for example, behave, and so on. And this is very useful. Also, a lot of the companies we work with, they predict growing, let's say, connected devices they sell. And so it's very important to understand, okay, what would happen, let's say, if I double my sold devices every year or so? How would my backend infrastructure, how would it look like? What does it need to do? And the same is also true for the industrial IoT space, for example. So what would happen if I add, let's say, 2 new machines or a new gateway into my infrastructure? What would happen if I, let's say, add a new, let's say, a SCADA system? For example, if you're going to Sparkplug infrastructures, what would happen if I add a new primary application or a few new secondary applications to be in the Sparkplug space? So all this kind of stuff is something companies really try to figure out, and this is so hard to do. And sometimes people just realize in production what's happening. And this can be, as we have seen, can be very costly. So from a feature perspective, what can you do? And then we will also show a live demo, and we dig into the details how, from a technical perspective, you can do things. You can build these reusable and declarative scenarios, and this is huge because you can put it on version control, you can modify it, you can copy it, and so on. And so you can even build your own library of different scenarios you want to test, and test it also in an automated fashion. Then there's a local and distributed setup. You can just start Swarm locally in your machine, no setup required, basically just a command line tool. Or you can go the distributed setup way, where you can have literally hundreds of data generators around the world, which you just, with a command line tool, you just start the scenarios and stop it and create really large scale tests. Swarm supports currently up to 10 million real MQTT connections. So this is something we support right now. Officially, we have seen like anecdotes from users who let's say exceeded that by large, but this is what we officially support right now. In case you want to test more, talk with us, because this also might get a problem from an infrastructure perspective. But this is possible. It really scales extremely well. It has built-in monitoring, logging, and reporting. This is important, and we will also see this in the live demo. There's a REST interface available, which is Prometheus compatible. This means you can also bring this into your centralized infrastructure. And as I said, we support custom data generators. It runs everywhere. And in case you're not using this already, there's the MQTT command line interface, which is an open source project. We also have a MQTT CLI integration. So if you're using the MQTT CLI for developing your MQTT applications already, this now also integrates neatly with that. So you can actually use Swarm directly with the MQTT CLI. So how does this look like? So usually we have the system under test, which usually consists of an MQTT broker like HiveMQ. And then you have a lot of applications. You have things like Apache Kafka, you have microservices, you have sometimes databases, and really a lot of systems you want to test. And this is your whole system under test you want to run the load against. And then there's the simulation environment. In this example, we are running on Kubernetes. But as I said, you can also run it locally. You can run it like on virtual machines. Swarm doesn't care where you run it, actually. And then you have a commander, which is a central application that is responsible for distributing the workload to all the agents which generate the load. And you can scale your scenarios by adding more agents, which then simulate the real MQTT clients. And you can, again, literally have hundreds of agents, depending on what kind of load you want to have and what you want to test against. And then there's a built-in reporting database and a dashboard available. And but you can also integrate it neatly and nicely into your centralized infrastructure. So if you have already a Prometheus, if you have a Grafana or InfluxDB or anything else, Swarm can integrate with that very nicely. And then there's Swarm control. It's usually your machine. This can be your continuous integration server like Jenkins or something else. This is really something you test your commander against. So how does the workflow look like? This is pretty simple. You're creating a scenario, which is text-based. So you can modify it. You execute it in a simulation environment, which you just saw. Usually the workflow includes grabbing a cup of coffee or some other beverage, and then look at the reports. And what is nice though is you can look at the report live. You don't need to wait until the whole scenario was done. You can look at it live. And then you repeat it, like with higher load, with lower load. You look at all your system under test, how it was behaving. If your goal was to break it with a stress test, you can check if your system broke and where it broke. If your goal was to do functional testing, then you can check your application, what happens, and so on. So this is extremely flexible. And by the way, we will see in detail how to create a scenario and what is in here and how this looks like. But before I go any further, and before I show you a demo, just a very quick refresher on MQTT, because there might be some people who are not familiar with MQTT and would like to get a quick refresher here, because Swarm is built for MQTT. And so I think it's important for people not familiar with MQTT. Chances are, if you're doing IoT, you're already using it. Also, most cloud platforms use a proprietary version of MQTT for their cloud connectivity. We are talking here about the full MQTT, though. So Swarm supports the full MQTT specification, of course, 3 and 5, MQTT 3 and 5. So, but for people not familiar, MQTT is an IoT messaging protocol. It's based on a publish-subscribe pattern. It has a minimal overhead for clients, and it has a very minimal overhead on the bandwidth side, so it's pretty slim. It's designed for reliable communications over unreliable channels. So if you have things like cars which require mobile connectivity, then you would need something like MQTT because you have an unreliable channel. It allows, and this is huge, bidirectional communication. So our MQTT client connects, as you see here, to a central broker which distributes data, and you decouple all your producers of data and your consumers of data with a publish-subscribe architecture. And MQTT allows for bidirectional messaging. So if you, let's say, your smart sensor here on the left is connected to the broker and publishes data, it could also subscribe to data and use the same channel for exchanging data bidirectionally. And this is very important and also pretty unique. Especially, there are also a lot of features which are not listed here about MQTT, which are really built for connected products and also for industrial IoT applications. So because the benefits is it's lightweight and efficient, as I said, that bidirectional communications, you can scale to millions of things or connections with MQTT, which we will see in a second with Swarm. It supports reliable message delivery over unreliable networks, and you can make it very secure based on the same standards the web is made secure with TLS, for example. It uses all the best practices. You can have, so your usually MQTT brokers like HiveMQ built for enterprises integrate with your PKI. You can use client certificates. You can use simple username passwords as well as tokens like OAuth tokens and so on. So MQTT is really built for security. Okay, but before, I think some people are now wondering, okay, what does it look like? How does a demo look like? I would like to hand over to Georg, who will show you a quick demo and then walk you through about some more details of how Swarm actually works.
Thank you, Dominik, for the introduction into Swarm and MQTT. And you are all right now, very excited to see our demo, I guess. So let me just start it. If my demo works, yes, it works. So what you can see now is how it would look like if you do a Swarm scenario. You write some text. We will go into detail on how this text is structured. So far, it is an XML file. And then you run a command on a command line, and you start the simulation. And now you get some logging here with all the simulation connecting. Like Dominik already said, we are connecting multiple agents. Once they are all connected, we get a status message that the scenario is running, and this message says scenario in progress. We are right now in stage 1, so a scenario can have multiple stages. And now we see in a dashboard, so this is Grafana, and a lot of you will notice how this will look. And what our scenario does right now is scaling up, ramping up. We are connecting all our clients, and you can see on the left the number here. So this should reach 1 million in a second. And just like that, there are a million MQTT clients, real MQTT clients. The next stage in our scenario says the half of them, we call them subscribers. So this is a synthetic scenario, of course. They should subscribe. And so they do that. And once they are all subscribed, the other half will start publishing. And we've chosen for this demonstration an interesting pattern. This is not easy to do if you're just randomly connecting clients. You need to really orchestrate to have such a pyramid-shaped pattern. We are ramping up to like around 5,000 messages per second. Overall, this scenario has 2.5 million messages that go one way. So actually, it's 5 million messages both ways. And after the scenario is done and all the messages are published, the Swarm tool neatly shuts down and is ready for a next run. So as you see, all is well. This was very quick, of course. I will go into detail what goes into a scenario and how a scenario could look in your use case. So, like Dominik already said, a scenario is declarative in basic structure. So it is split in two parts. One where you declare the environment, and the second part where you declare the execution. Why is this important? You don't want to have like to manually build the stuff up. You don't want to say, okay, connect 1,000 clients here, connect 1,000 clients here, and do some stuff and then do some other stuff. This is very error prone, very hard to get right. What you actually just want to say is, I want 1 million MQTT clients. Make that there be 1 million MQTT clients, and Swarm will do that for you. Additionally, you don't want to like tell every client which topics they should use, which structures of topics they should use. You just say, okay, I have this topic structure. This looks like this. We abstract this away in a topic groups. And you say, Swarm, do that, make the topics look like this, and Swarm will do that. And but this is not all what you need. You need some complex behavior. Like Dominik already said, clients can be very organic, especially if they are cars or if they are anything that a human interacts with. They can show very complex behaviors, very unpredictable behaviors, and we need some way to go from this purely decorative, decorative syntax into a more imperative syntax for exactly reflecting this behavior. And that's where the second part comes into play. This is the scenario execution. We have different levels of synchronicity here. So some things will be after one another, some things will be at the same time as something else. So this is really flexible, and this can all be in multiple stages. So we make a decision point here. What is one stage? Stages are always after another. What is in one life cycle? Life cycles in one stage are all at the same time, and so on. And then what the actually commands be. I will show examples for this all in a second. So how does the declarative part look like? So this is a basic XML file. We definitely define at the beginning, we define our brokers. So this is all about MQTT. So the broker goes at the top. And you just say, okay, my broker is here, it is reachable. These are the connection information. That's it, what you need to know about my broker, just there. Swarm does not, of course, control the behavior of the broker. The broker is an external thing that you test with Swarm. Then you say, I want my client groups. In this case, it is very basic. We just want 25 clients. Let me just get my mouse pointer. I hope I can, like this. So we just want 25 clients, and you just say, here be 25 clients. They have this client ID pattern. This is like expanding. So to fill all for 20, we have 25 unique client IDs at the end. And the last part, you say, I want my topics. And again, you just say, my topic should look like this, but I don't want to define every single topic that my clients use. I just want to define a group of topics that are all very similar and very matching to my use case. So usually you have some intrinsic topic structure in your deployments, and you want to have some clients that interact with some topics and some clients that interact with some other topics. And you just say, here, this topic group, it looks like this, generate all the subtopics and all the stuff that is in there for me. Then we come to the execution part. The execution part is again XML, so there's no difference. But now we come into this into this ordered, so in a time-mannered ordered execution. You say how the clients should behave. Should they connect? Should they publish? Should they disconnect? Should they subscribe? And should they repeat it between that? And you can see there's a lot of ordering possible. But of course, if you want to, you can do a lot of things at the same time to test, for example, if you have some racy behavior in your backends, or if this makes any problems. So you can, of course, design your life cycles that some clients connect while others disconnect, while others start publishing, and so on, to have a really organic picture at the end. This is all flexible and possible. But so we say a scenario is well and fine, but what is about the data? So without the data, the scenario is just an empty shell. So the data is what encapsulates your business logic. And in a real life MQTT environment, there's really a lot of data and really of different parts of data. There's, of course, the published payloads. Everybody thinks that this is the first thing that comes to mind if we think about data in an MQTT scenario. But there's much more, and you have seen already some of this. There are topic filters and the topics. So the topic filters are for the subscribing part. The topics are for the publishing part. There is authentication, authorization information. And this is, I can't stress this enough. So I come from a security background, and IoT security, we will come into detail on this later, is a must. And this is data as well. So this needs to be processed somewhere. Then we have, with MQTT5, we have user properties and a lot of more things that can be data. The important thing is that this data is on top of MQTT. So it encapsulates your business logic and is what you want, what you really care about, actually. So HiveMQ Swarm is built to either have provide very generic data for a quick test. So if you want to do stress tests, you don't need this huge complex data. Usually some random data would suffice. But of course, you can do that. So you can, if you really want to do functional testing, you can go into the detail and define until the last bit of every message, and actually after that bit of every message is sent, and really define this into detail. And the important thing what Swarm does here is not leave you alone with your data. So what Swarm does is it takes all this generated data and distributes it across the deployment for testing. So you do not need to manually think about, okay, I want to create this data in this data center and this data somewhere else. Swarm will do that for you. You just say, take the data, distribute it, and send it to my MQTT broker, and Swarm will do that. How does it look in details? You have already seen one basic form of data generation. This is like in the topic, in the publish command. So this is one of the commands I showed you before. You just say, here, let's generate some random bytes. Perhaps your payloads are all encrypted, so this is perfectly fine. From an outside perspective, this would be random bytes. So this is okay, this can be fine. But it can be that it's not fine, that you want really precise data. And so you could use Dominik already teased it, the plugin SDK for that, and just say, okay, I want to really create my data to fit my use case. And I've just provided you a very sample payload generator, very basic here. It generates Spark-Plug test data. If you want to learn more about Spark-Plug, you can always talk to us, and we would be really interested to introduce you to this great new development in the MQTT world. I already talked about it, security. Why is security so important to have it in a testing environment? Security is in IoT a must by now. There is virtually no production grade IoT deployment anymore that has not highest grade security, because we had a lot of incidents in the past, you know that, and this is a state that the industry needs to go to think about. Everybody now does encrypted web traffic, and encrypted IoT traffic is a must. But security systems are usually very big. They are company specific and they are difficult to interact with. Security systems are more often shown in place, so they are usually not designed with an IoT mind in focus. They are usually defined with an people security mind in focus, and so you have to interact with already existing security systems. And security systems can very often be the bottleneck of a deployment. So security systems need to do a lot of processing, need to have a lot of complicated intrinsic logic, for example, encryption. And this is something that needs to be tested. And if your deployment, so if your testing of your deployment does not incur with security, you have a huge blind spot somewhere in your reliability, because if your security system is down, this is usually a single point of failure. So if the devices cannot authenticate, they cannot interact with the rest of the deployment. And that's why HiveMQ Swarm enables the testing of an entire IoT security deployment, including everything. So how does this look? This can again be very simple. If you have a basic use case, simple is fine, simple is great. So for example, HiveMQ Swarm comes with full TLS support out of the box. Doing TLS with HiveMQ Swarm is as easy as defining TLS as transport and setting the port number to the right port. So 8883 is the TLS port for MQTT. And that's it. TLS works. You have encrypted connections. And this is the first step of doing a security testing. Then you can do basic authentication. This comes out of the box. We have a standard security plugin for this. And this provides basic authentication. You just provide credentials. You can provide single credentials. You can provide complete files of credentials. So if you have a multitude of clients, they usually would not use all the same credentials. So they would have, every client would have its own credential usually. And you can provide that. You provide it in a structured file format, and HiveMQ will take that file format, distribute it, and HiveMQ Swarm will take that file format, distribute it, and run it. But that may be not enough. Maybe you have more involved security because you're using an enterprise-grade system. And this is, again, where the SDK comes into play. You can do virtually any security integration you like with this. For example, what I really love to see in production-grade deployment is using OAuth services. I feel they are really good suited, really fit for IoT workloads. And so you would just integrate with your OAuth service. It could be an OAuth provider in the cloud, or it could be an on-premise OAuth provider. And then tell Swarm how to interact with this. And Swarm will do that. And then you just parse the information that you get from your OAuth provider and put it somewhere in the authentication data places of the MQTT protocol. So there are multiple places where this can be put. The most basic one would be username and password, but there are, of course, other options. And HiveMQ Swarm will do that. And every time it creates a new client, it will do the authentication logic like a real device would do, get the authentication information, and provide it to the broker with the MQTT messages. Last thing, before I hand back to Dominik, is how is Swarm set up? So it is a distributed setup. We already had this really nice picture with the whole world connected to an MQTT broker, centralized. And if you want to simulate that, HiveMQ Swarm gives you the tool to set this up exactly the same way. So one part of your, so one agent of your Swarm deployment could be, for example, physical in another location in another part. And as long as they form like somewhat reliable network connection, you can do that. We have here an example in a Kubernetes cluster where everything runs in Kubernetes, but it could be that only the agents run in Kubernetes, or only the commander runs in Kubernetes, and it talks to the agent in some public clouds. For example, you have some data that comes from Azure or some comes from AWS. Or even you have some simulated data clusters in an on-premise data center in your factory shop, I don't know, in northern Russia, and you want to test that. So just put an HiveMQ Swarm agent in your data center in northern Russia, and you can do your simulation from there. So this really allows you to precisely simulate how a real workload would look like. And that's it from my part for the technical details, and I will hand over back to Dominik for the further steps.
Okay, thank you, Georg. So we have seen a very quick introduction of what you can do with Swarm. So actually, this was what we've just seen is really just a very quick overview. Swarm is extremely powerful. So there are a lot of things like you can even simulate this kind of reactions. So let's say if you have a very complex workflow, you can build that. So there's really a lot we can do. This unfortunately is not in the scope of this webinar, but we have an extensive documentation available. But also, of course, for our customers, of course, we have also trainings available and so on, which go in detail how to do this. But I hope you've seen how easy it is to create very, very complex workloads, which so the customers we provided early on, they're raving about it by saying, okay, this like literally took us weeks or even longer to develop this kind of behavior. And now it's a matter of a day by creating a scenario. And we have built with Swarm, we have built the most complex spark plug scenarios. We have built connected car scenarios with more than 60 microservices communicating over MQTT with organically moving devices and so on. So this is really powerful, what you can do. And even for the most complex scenarios, you just have even for the most extreme cases, like a few hundreds lines of XML code, which you can also actually generate yourself in case you have some other systems putting out the data. So what are the next steps, and also how can you get Swarm actually? So first of all, HiveMQ has the enterprise MQTT platform, which mainly consists of the MQTT broker and other components like the control center or extension SDK, with a lot of out-of-the-box connectors to things like Kafka, to databases, to most security systems, be it OAuth, be it LDAP, be it client certificates or whatever. So HiveMQ supports a lot out of the box here as an MQTT broker, which is used here for these enterprise-grade mission-critical deployments. And also here you can run it, of course, everywhere, the HiveMQ platform. This is also one of the things. So multi-cloud deployments are something we see a lot these days. And HiveMQ Swarm actually is now part of this platform. So now as of today, we started an early access version, which you can download today. I will show in a second how you can get it. And with the next major release of the HiveMQ platform, you will get Swarm basically out of the box with the platform. So there's no additional installation required here. And similar, as some people probably know, the enterprise MQTT platform of HiveMQ has a free trial, which allows you to use 25 MQTT clients. The same is true for Swarm. So as a trial, without talking to any, let's say, salesperson or whatsoever, you can download Swarm and try it for up to 25 devices yourself and create scenarios. So as of today, as I said, we announced HiveMQ Swarm. You can get it on our webpage. So you can either scan the QR code here on the left, or you just go to hivemq.com/HiveMQ Swarm. And you will see basically, again, some of the features. We will also add over the next days and weeks some additional resources you can see. And yeah, you can download it today. You can try it out. This is an early access version. And yeah, we would be very grateful to have any feedback if you have one. And this is a tool, and this is just, by the way, this is not a tool we came up with just recently. We built Swarm because we basically needed to scratch our own itch. As you know, HiveMQ is a very scalable platform, which is used by Fortune 500 companies around the globe. And we use Swarm every day, like actually 24/7 all the time, for testing our own software a lot, for literally testing customer scenarios, the most common customer scenarios all the time, to make sure that even the most ambitious workloads and scale can be also done with our platform all the time, and we don't have any regressions. And now we will make it available for our partners, for our customers, and also for other folks who want to try this out. And also something I haven't talked about, partners. So all our HiveMQ partners also get access to this tool. So just reach out to us, and we talk about the next steps here. In case you're not a HiveMQ customer, you can still use the Swarm early access by today. You can download it, take a look at it, also give us feedback. And yeah, so this is really something we believe will change how IoT testing is done and will be done in the future. And so yeah, and this certainly will grow, because testing is so important. And yeah, and this is our take in order to fix that and democratize large-scale testing, and make it available to all our customers and partners. Okay, I think we now have still a bit of time for questions.
Yes, we still have. Unfortunately, there have not been. Oh, now the first question pops up. Rolf asks, if you have special needs, the XML is not enough, you can use the SDK, right? How easy is it to implement new logic, load specification, topic constraints, etc.? You showed us the Java SDK. Do you have it in another language?
Okay, so currently this is built for Java. So officially supported as of now is only Java. So if there are many, the cool thing about the Java platform is that you could use also different flavors. So like, for example, there's JRuby available, Kotlin, and a lot of other things. This is not officially supported though. But similar to the extension SDK we have for our MQTT broker, we heard anecdotes that people are having good success with that, but it's not officially supported as of now. If there would be any requirements for that, I personally would be very interested in that. But for now, we only support Java.
For the first part of the question, perhaps, so it is very easy in my opinion. You basically get all the, so from talking from a developer standpoint now, so you basically get all the information about where your agent is right now, what it is doing, in what state it is, and then you can just say, okay, you just need to return the payload you want to send out. So for example, if you want to return an protobuffer, you just create a protobuf, give it to Swarm, and Swarm will send it out over the MQTT connection.
Okay, so don't be shy. There's still some time for questions we can answer.
Probably you just explained everything too good.
So we also have a
question in the chat here.
Yeah, if we send out the slides, yes, of course, we always make our recordings available here, and yeah, so you can always watch it. Again, try out HiveMQ Swarm. Also talk to us if you like to learn more. We also have a community forum about all things MQTT and our products. So you can also reach out here. So, and this is something I want to stress, even if you're not a HiveMQ customer, you can still try it out. And the community forum is also here, where a lot of people are helpful and help you on your journey with testing and MQTT. Okay, and then another question is Swarm available as a standalone testing tool without a 25 restriction? Yes, of course, and I think I was not clear enough on that. So thank you for the question. So HiveMQ Swarm will be distributed with the HiveMQ platform. You can use it without HiveMQ, absolutely. And the testing restriction is just a trial. So also for an extended, let's say, trial, talk to us. We happily provide, let's say, larger or even unrestricted testing files, so you can try it out yourself. So yes, absolutely. And the download that we just presented is actually, the standalone tool. So, but in order to make it easier for the users, we also distribute it with the HiveMQ platform in the future. But for now, it will always run standalone. You can also test it against other MQTT brokers. We feel it is best if you do it against an enterprise-grade broker like HiveMQ to test against, but you can also test against other MQTT brokers if you have it. And Okay, there's another question about the cost structure model. For the cost structure, best would be if you reach out to us. So for now, until HiveMQ 4.6 hits the store, this will be available as an early access. And for the cost structure model, best would be to talk with your existing customer to your account executive, or reach out to us directly so we can walk you through also specific to your situation. Okay.
There is one question now popping up in the Q&A tab by Vinye. He asks, can I download the reports after the load test?
Yes. So this is so we integrate on the one side. We integrate with other reporting systems. So depending on what you have, you can have it here. Or also this is plain Grafana we have. So all the things like the API and also the download functionality and so on is of course also available for you then. So absolutely yes. Yeah. There is not a PDF export at the moment right now out of the box available, but the charging system allows for that.
Oh, the questions come in. Great.
So Kieran asks, how does it support functional test automation for IoT apps?
So so I'm not 100% sure about the scope of this question, but I'll try to give it a take. So it supports functional testing in the way that so basically you can generate the inputs and also validate the outputs of the system under test with Swarm. So even if you do not do scale testing, you can simulate the expected behavior, basically throw it against your application, which will also get the data from the MQTT broker, and then you can also make sure that the output is what you expect. So this is especially useful if you are in a continuous delivery or continuous integration environment. So you can make it let's say basically an automated testing you have all the time. And by the way, you don't need to start a new Swarm command all the time. You can just have it run it here, use the REST API to push in a new scenario, run it. And so you don't need to set up the whole Swarm infrastructure all the time. You can just create it once and yeah, run your scenarios all the time, anytime you want.
The important thing is you can adapt these scenarios. So that the nice thing is, as the scenarios are in a file, in a plain text file, and they can be collaboratively worked on. So they, as already Dominik said, they can be under version control, for example. And so can you really iterate on having the best possible reflection of the true world in your test environment.
Okay. So okay, there's another good question.
Oh, this is getting really into detail. Yes. Okay. Should I read the question or?
Sure, go ahead.
Yeah. So the question is, how would you model a dynamic load, like no traffic, sudden spikes, iterative height loads, by a sequence of stages with each having their life cycles, or question asking to confirm I understood you. You actually understood it perfectly. So you can do it with all of them. So you can do it with stages. So in like stages, however, if a hard happens after in conjunction. So one stage will always happen after the previous stage is finished. Or you can do it with life cycles. This will in one stage, life cycles will have a parallel execution. So two life cycles in one stage will execute at the same time. And exactly like this, you do it. So you define a stage with a high load and you define a stage with a low load, or you can even do it in one life cycle with different commands after another. So for example, you do a publish command with a low load, and then you do a publish command with a high load directly afterwards. And then you will have really spiky patterns if you like. So as you've seen in the demo, you can do it very precise. So this was like so the maximum peak in the demo was at 5,000 messages per second, and it went up, I think, in 500 messages per second steps. And this was like all orchestrated and really precise on the 500 message increment step. So yes, you do it via the sequences of stages and life cycles.
And there is another question. Kieran asks, thanks, security testing is important in IoT world. How Swarm will address this? So it's about how Swarm will address security testing.
I'm not 100% sure how the scope of this question is. So it is not a penetration testing tool. If you're going to that, it is integrating into security. So it tests your security system in the way that your security system as part of your whole IoT deployment. But what Swarm does not do is penetration testing. There you would need to go to some other resources. I hope this answers the question.
Okay. So I think we got through to all the questions. So thank you again, everybody, for the good questions also. And thank you for tuning in. I hope you're as excited as we are about this tool. So let us know. So you can also, as I said, you can always contact us and reach out to us. So you should now see the contact data. Contact me directly or also contact Georg if you want. So you can also reach myself on Twitter and on our LinkedIn. We're happy to help about any questions. So thanks again and have a good evening or a good start into the day.
Yeah.
Thank you very much for joining. Bye.
See ya.